Hi everyone. Welcome to a set of videos about infinite series. This topic is often learned in a calculus class because it deals with infinity, but you don't need to know calculus to understand the content of this video. Before we begin, it would be good for you to identify what ideas you already have about adding numbers. Pause the video and ask yourself the following question. What is the sum of an infinite number of numbers? Well, I wouldn't be making these videos if the answer was straightforward. The answer is that ever frustrating depends. Through a handful of examples, we'll try to lock down what we can conclude and what conditions are important. Let's jump in. In this first video, we'll establish some terminology, notation, and basic examples so that we're all starting with the same foundation. In the next video, we'll delve into more examples. Please make sure to continue watching so you get the entire concept. Let's start with some terminology. A sequence is a list of numbers. If it has a set number of terms, it is called a finite sequence. If it continues forever, it is called an infinite sequence. A series is the sum of a sequence, or the sum of a list of numbers. If it has a set number of terms, it is called a finite series. And if it continues forever, it is called an infinite series. Looking at this finite sequence, what do you think this sum adds up to? Well, we just add the numbers. 1 plus 2 plus 3 plus 4 plus 5 comes out to 15. But even if this sequence had 100 terms, the sum would be finite because eventually we stop adding new quantities. So what do you think this sum adds up to? Your instincts might tell you that this sum is infinity. Because you're continuing to add more numbers forever, and those values are growing in size, this sum cannot settle down. Since the individual values of the sequence is approaching infinity, the value of the series, meaning the sum of all the terms, is also approaching infinity. Just a couple more terms that we need to establish. The terms convergence and divergence apply to both sequences and series. When a sequence or series approaches a finite value, we say it converges. The value that it approaches is called the limit. When a sequence or series does not converge, we say it diverges. This is only really interesting for infinite sequence and series, because all finite sequences and series must converge. Divergence can happen if the limit approaches infinity, or if it doesn't approach anything in particular. We already saw an example, 1 plus 2 plus 3 plus 4 plus 5 plus ... where the sum approaches infinity. This infinite series diverges. But what does it mean to approach nothing in particular? One such example is oscillation. Suppose you have a sequence with the terms 1, 0, -1, 0, 1, 0, -1, etc. The sequence is bouncing or oscillating and can't seem to make up its mind about where it wants to go. It isn't going to infinity, but it also isn't going anywhere in particular. So the sequence diverges. What about the series? If we observe the trend in the partial sums, the sum of the first one term is 1. The sum of the first two terms is still 1. The sum of the first 3 terms is 0. The sum of the first 4 terms is 0. And the sum of the first 5 terms is 1. As we continue to add more and more terms, this pattern repeats in pairs of 1s and 0s. The sum isn't growing towards infinity, but it also isn't approaching anything in particular. So the series diverges. As I mentioned before, convergence and divergence is only really interesting in infinite sequences and series, and the goal of this video is to help you understand how to think about infinite series and what it means for one to converge or diverge. We've already seen an infinite series that obviously diverges. 1 plus 2 plus 3 plus 4 plus 5 plus dot dot dot. This is a good time for you to check your intuition. Does any infinite series necessarily diverge? I mean, we are adding forever after all. What do you think? We'll investigate this in the next video. Stay tuned. I hope you enjoyed this video. See you next time.